All right. So we are in the middle of 2.3. So part of that was solving equations. So hopefully you spent a little bit, if not a decent amount, a little bit of time over the weekend getting a head start on that assignment. I will tell you that this unit quiz, which again is open notes, but it covers 2.1, 2.2, 2.3. We're finishing 2.3 today. So that quiz is going to be on Friday in the class. I'll tell you a little bit more what that looks like. Okay. All right. So just to refresh our memory on where we were at, because we were in the middle of an example. So we were looking at the oxygen consumption for males, for females. So we were given two different equations. And if you recall, the part A dealt with the function being the female. So we used that function formula. And the variable was P, which is the number of 15-second pulse count. Now in part B for the males, same variable, but now our function dealt with males. So, sorry, had a thought. Okay, dealt with males, so we use the other formula. Now, also the difference in these two. So let's look at part A, and you can see that the functional notation was F at 40. All right, so what was given, function or variable value in part A? We were given the variable value in part A. All right, and then just as a reminder, in part B, they gave us not the variable value, but the function value. So that means that we were looking for the variable. So we had to do some algebra with our equation. Okay. All right, so that's just a reminder of what we were doing. All right, part C. What 15-second pulse count will indicate the same maximum oxygen consumption for a male as for a female? What mathematical word can we use in place of same? It means they are what? Equal. Okay. So what they're telling us is they want to know what the variable is when your two functions are equal. All right. So what we're going to do is we're going to take the male function, because we know when they're equal, we're saying the male oxygen consumption is equivalent to the female oxygen consumption. So in place of M, we're going to put 111.3 minus 1.68 P. And that is equal to my female function, 65.81 minus 0.74 P. So they're wanting to know what 15 pulse count. So they're asking us to find P. So I now have an equation with the only variable is P, so that what we're going to do now is solve this for P. So as we looked last week, the equal sign is what separates my equation. I noticed that I have a P on both sides. So we've got to move one of the P's to the other side. You can move this P over here, or you can move this P over here. As long as you do all your steps mathematically correct, we'll get the same answer. For purposes of this class, I'm always going to move the variable to the left side just because that's what we're most familiar with. So I want to move minus 0.74 P. I want to get rid of it on this side. So what will I do over here? Add it. So I'm going to add 0.74 P. And so now we're left with 111.3. And then these two have the same term. So what we do is we add or subtract their coefficients. So I'm just gonna put in negative 1.68. And I'm gonna add that to 0.74 to see what I would get when I combine those, and I get negative 0.94. So this would be minus 0.94 P equals, and we're left with 65.81. All right, so now my P's are all on the left side. So I need to get that P term by itself. So what do I do on the right side if I eliminate it on the left side? I'm going to subtract it. So I'm going to subtract 111.3. So now I'm left with negative 0.94 P is equal to, and then go to your calculator and do 65.81 minus 111.3 and tell me what that is.
Negative 45.
Point what? 49. Okay. All right, so we're pretty close to getting the P by itself. It's being multiplied. So to undo that, I'm going to divide by the coefficient that I want to get rid of. This cancels. So P, which is your pulse count, and that makes sense because now a negative divided by negative is positive. Give that to me out to 3 decimal places. What did you calculate it? 3936. So that would round to 4. Yeah. So be careful on rounding. Now, what is this?
15.
That's your 15-second pulse count. Because remember, that's what P was in both of these. So we had just found P, which is your number of 15-second pulse counts. Okay, all right. Now, this does not ask for this to show, but I think I want to take the time to do something on our calculator because I think it's important for you to see how the things we do on the calculator actually relate to what we're doing. So I want you to go to your equations, y equals, and if you have any equations, clear them out. And in y1, I want you to put the male function. And in y2, I want you to put the female equation. And so it should look like this. Everybody good? Okay. Now, my variable is P. In my calculator, what letter represents this P? X, right? So we're kind of looking at, we're going to look at our table, and we're looking at when X is equal to 48.393, what is true about your two function values? They'll be equal. When the two function values are equal, this is my P. Okay, so here's what we're going to do. Go to table set. And we're going to start at 48.39. So do that as your table start. And then your change in table, I want to go 3 decimal places. So I want you to put in 0.001. Then I want you to do second table. And this first column is my X, and my X is 48.394. So I'm going to find the 48.394. Y1 is the oxygen consumption for my male. Y2 is the oxygen consumption for my female. What do you notice about those two values? They're the same. And isn't that what we're saying when we set them equal to each other? So you can see it on the table as well. Was that you that we were looking at this on? Yeah. So this was asked on Friday, and so I was thinking about this morning, I was like, oh, let's go in there and look at that. So I went a little bit further out 3 decimal places so we can see where it's actually equal. Okay. All right, now part D. What maximum oxygen consumption is associated with your answer in part C? Okay, so in relationship to this question, had we not gone into the table, what we're saying is what happens in both of our, so part C, we were given P equals 48.394. So it's saying in part D, what is the maximum oxygen consumption for my male? And what is the maximum oxygen female consumption for my, female. Can't talk and spell at the same time. Right? So I'm going to go to my original equation of male, and that I want to find the male oxygen consumption at the pulse rate, 15-second pulse rate of 48.394. And then I'm going to do the same thing for female. Now, we can look at the table. What answer should we get when we plug it into the formula? 29.998, okay? But what we're going to do is we're going to find or look at the male equation, and we're going to substitute it in. So 111.3 minus 1.68, and we're going to multiply times 48.394, and we're going to confirm that that's the value we get. So I'm going to do second quit. And I'm going to put in 111.3 minus 1.68 times 48.394. And if you rounded that to 3 decimal places, we get 29.998. So now we're going to put it into the female equation, 65.81 minus 0.74 times 48.394. And we know we should calculate what? 29.998, but I'm going to confirm if that's actually what happens. Now, it's not out 4 and 5 decimal places exact because we rounded this number. But if you round this to 3 decimal places, we again get 29.998. Now, what are these two numbers representing? The oxygen consumption, which was measured milliliters per kilograms. So milliliters per kilograms. Milliliters per kilograms. So if this were on a test, then you would want to show me the work. Instead of show me the money, you're going to show me the work. Okay? All right. In everyday experience, the measure of temperature most often used are Fahrenheit F and Celsius C. The relationship between them is given by the following formula. So here's our Fahrenheit degrees. So when I am looking at this formula, what is my function? Fahrenheit, which is F. What is my variable? C, which is Celsius. Okay. Physicists and chemists often use the Kelvin temperature scale, and you can get kelvins from degrees Celsius by using the following formula. All right. So in this formula, what is your function? Kelvins, K kelvins. And then what's your variable?
So
C Celsius, okay? All right. So, part A, explain in practical terms what K at 45 means. All right, K at 45. This is called functional notation, right? So, based upon this functional notation, what is your function? K, which is Kelvin temperature. Now, I don't see a letter for the variable, but how can I find what the variable would be? Where would you go looking? In the equation, right here, right? So if K is my function, then my variable is C, which is degrees Celsius. If you put just Celsius, that's fine. Okay. All right, so now that's going to help me explain in practical terms. It hadn't asked me to calculate it, so all I have to do is explain this in practical terms. So how do you explain the K? Yeah, the temperature in Kelvin or the Kelvin temperature. At what? 45 degrees Celsius. And we don't know what it equals yet because it hadn't asked us to do that yet. So this is all I would put on the explain. Now, the second part says, okay, go ahead and calculate that value. So now we're going to do K at 45. So that will be 45 plus 273.15. So it's just a matter of adding those. So what do you get? 18. All right, so 318.15. What? Degrees Kelvin or Kelvin temperature. I don't know if Kelvin's done K from degrees Celsius because it doesn't say the word. If you gave me degrees Kelvins, that'd be fine. I don't know if they do that in degrees, so I'm going to say Kelvin temperature, but I would take both. I don't know enough about measuring it. I just know if it's hot or cold outside. And I'm lacking the better weather. All right, B, find a formula. Okay, well, when they're telling me to find a formula, I know I'm going to probably have to do some manipulation of a formula, right? Okay, so it says expressing the temperature C in degrees Celsius as a function of the temperature K in kelvins. Okay, because of that wording, they're wanting me to find a formula, but ultimately I want the function to be what?
so C.
C. And I want the variable to be what? K kelvins. Okay. All right, so we're using C and K. So I'm going to come up here and I'm going to look at my two formulas. Well, this, I have to be careful how I say this. I said this in my 930. I said this has F and C. Well, that didn't sound very nice. So this has the letter F and the letter C. Those aren't the two letters that, did you catch it? Those aren't the two letters that I want. So I'm going to come down here and we have K and C. Okay, so I'm going to write that formula. K equals C plus 273.15. Okay, right now, how it's written this way, what is my function? K, and what is my variable? C, but it wants what to be my function? C. So because it wants C to be my function, that means I will need to take this equation and, or this formula and solve for C. Okay, all right, so I want the C all by itself, so the only thing I need to get rid of is this plus 273.15, and if I move it to the left, I subtract it. So we have K minus 273.15 equals C. And if you put a box around that as your final answer, I would give it as correct. But since we're typically, when we talk about functions, we put that function function letter first, I'm going to rewrite it as C equals K minus 273.15. Now I have it, function C, variable K. And that's what it asked me to do. All right. Part C, find a formula. Okay, that tells me I'm probably going to have to find a formula that I don't have yet. So it wants me to express the temperature F in degrees Fahrenheit as a function of the temperature K in kelvins. Okay, so based upon that wording, what do they want the function to be? F, which is degrees Fahrenheit. And they want the variable to be K Kelvin temperature. All right, well, if I go searching, this formula has the K, but it has a C. This formula has the C and the K. This formula is the only one that has an F. So I'm gonna have to start there because it's the only one that has the letter F. So F equals 1.8 C plus 32. Now, if they wanted the function F and the variable C, we'd be done. It's already in that form. But we need the variable to be K. There's not a formula anywhere that I can find right now that has the F with the K. So, any thoughts on what we did in part B that might be helpful for part C?
Yeah, C from the previous into a C in Fahrenheit.
Right? So what he's stating is, can we take what C is equal to and replace it with this C? He said plug it in. You could say substitute. And yes, since they are equivalent, that's exactly what we want to do. So we have Fahrenheit equals 1.8, but in place of that C, I'm going to plug in K minus 273.15. Now be careful, you still have plus 32 that is a part of your formula. All right, so now we're going to simplify our formula. So the first thing that we're going to do is we're going to distribute that 1.8 through. So Fahrenheit equals 1.8 times K is 1.8 K. And then 1.8 times, we're going to get minus. So somebody do that multiplication and tell me what that gives us. Thank you. And then don't forget, we still have that plus 32. All right, now we're not quite done because these two numbers we can still combine. So we're going to have Fahrenheit equals 1.8 K. Now in your calculator, put in negative 491.67 plus 32. And what value do you get? And is that positive or negative? Negative. So since it's negative, I'll do minus 459.67. Now I have a formula. My function is F and my variable is K. So now it wants us to take that formula and it says, what is the temperature in degrees Fahrenheit of an object that is 290 kelvins? So right here, they're telling us that kelvins is equal to 290. So was I given the function value or the variable value in relationship to this formula?
Variable.
Yeah, thank you. Variable value. So we're gonna find Fahrenheit at 290 kelvins. So that will be 1.8 times 290 minus 459.67. Do they have that? Okay, so we get the value 62.33. What in the heck is your 62.33? Degrees Fahrenheit. So if we were gonna explain this, which could be a test question, the degrees Fahrenheit at 290 kelvins is 62.33 degrees Fahrenheit. Okay, all right. The number J in thousands of cans of frozen orange juice sold weekly is a function. Okay, so we know there's our function of the price P in dollars of a can. In a certain grocery store, the formula is, so here's the formula that is. All right, so what's my function? J, and what does J represent? Okay, so I'm gonna say, number of OJ cans. And this is in thousands. So if we calculate 5, we know, like if we get J equals 5, that means 5,000 cans of OJ, not just 5. All right, so what's our variable? What? P. What does P represent? So price in that per can. And if you put dollars in there, I mean, price, we know it's dollars just because that's what we live with. So if it was giving us a different monetary thing, we would definitely want to mention it. Okay, express using functional notation the number of cans sold weekly if the price of a can is $1.40. Okay, so here's what was given right here is $1.40. Did they give me function or variable value?
Variable.
All right, so my variable is P equals $1.40. How do I represent that in functional notation? J at $1.40, so that's functional notation. So we've answered the first question, so if you don't give me that and you just give me the calculation, you'll miss part of the question. It now says to calculate it, so it's just a matter of plugging it into the formula. And what value did you calculate? Now this is where you need to be careful. Is that $7.50? No, my function is the number of OJ cans, and 7.5 would represent how many? 1,000. So it's 7.5 thousand cans of OJ. Do you guys like orange juice? Yeah, some do. I'm not a big fan. Okay, are you team pulp or team no pulp? Really? If I'm drinking it, I'm team no pulp. It's like, what if something slips in there that's not pulp, but it has the same I don't know. Can't do it. Oops, and I can't spell 1,000. Okay. All right, part B. At what price will there be 7.25 thousand cans sold weekly? What's given? What value? Function value. This is where you need to be careful. This is the question on the test that so many students incorrectly get, because guess what they do? They'll do J at 7.25. Well, the formula is J equals 11 minus 2.5 P. You told me we were given the function value, so we were given J equals 7.25. So we're not calculating J at 7.25. That would be if that was a variable value. So in place of the J, you put 7.25. And then at this point, you will solve for P. All right. Again, most of you probably don't put that line, but if it helps you, please do. I want the P by itself, so I need to get rid of this 11 first. How will I move it? Subtract it. So what's 725 minus 11? I know it's going to be a negative number. Thank you. And then be careful on the right side. What are we left with? Negative 2.5 P. So now when I want to get the P by itself, I'm going to divide both sides by negative 2.5. So my negative 2.5s are gone. So I'm left with P equals, and now negative divided by negative is positive. What do you get when you put that into your calculator? 1.5. Okay, now this is where you need to be careful. P is the price per can. So how does this need to be written? $1.50. So you need to include that 0 per can. And based upon answers I got on exam 1 that had things similar, many of you guys will just give me 1.5. We're talking money. Please put phone. All right. Find a formula expressing P as the function of J. Okay, so now they want my function to be P, which is price per can. And the variable to be J, which is number of OJ cans in the thousands. Okay, so I'm going to go up to my original formula. Which currently is the function J variable P. And they're telling me I want it to be the function P. So they're asking me to do what with this equation? Solve for P. Get P by itself. And as you can tell, that's the theme of this unit in this section 2.3. All right, so if I want P by itself, we got to get rid of the 11. We did that above by subtracting 11, but the difference is now we don't have a value in for J. So J minus 11 equals -2.5p. And then just like above, when we were at this point, we divided both sides by -2.5. That cancels. So we're left with P equals, and my numerator is J minus 11, and my denominator is -2.5. Not necessarily a pretty formula, but now I do have it as the function P in terms of the variable J, which is what it asks for. Okay, at what price will there be 7.75 thousand cans sold weekly? All right, so now we're given what letter? We're given J, right? So we're given J equals 7.75. We're going to use our new formula. So it's asking for at what price. P represents price, and we know we want the price at 7.75 thousand. So this is now my J. So we would have 7.75 minus 11 over -2.5. So when you put that into your calculator, let me know what you calculate. 1.3. And be careful, this is your function P. P is price, so this needs to be written as price. What would that be? $1.30 per can. Okay. All right. Now, here's the good news. We are not gonna